Okay, let's be real. Have you ever had a critical data pipeline fail halfway through a write, leaving your tables just completely corrupted? Or maybe you've tried to reproduce a report from last quarter, only to find the data's been overwritten and is gone forever. Yeah, we've all been there. That's the classic data swamp. But what if you could bring the rock-solid reliability of a traditional database right into your data lake? Well, that's the promise of Delta Lake, turning that swamp into a pristine, reliable lakehouse. So let's dive in and see how it actually works. First, we're going to really diagnose the data swamp problem. Then, we'll uncover the secret sauce behind Delta Lake before digging into its two main superpowers, time travel and performance. After that, we'll run through a real-world playbook for how you'd use this stuff to solve a crisis. And finally, we'll cover the fine print you absolutely need to know. So let's set the stage. You know the drill. You're using something like S3 or Azure Blob Storage. It's cheap, it's massively scalable, but when you're just dumping raw Parquet files into directories, you are, frankly, living on the edge. Okay, so check this out. On the left is probably a familiar sight. It's that classic, kind of complex architecture. You've got your object store, sure, but you also need message queues for streaming, separate data warehouses. It's a lot, with data copied all over the place. Now look at the right. With Delta Lake, it becomes this clean, unified lakehouse. That same low-cost storage is now serving everyone. Streaming, BI, data science, drastically simplifying the whole thing. And here are the technical pain points that keep us up at night. No atomicity means a job writing 10 files can fail on file number 6, leaving your table in a corrupt, half-written state. Then there's eventual consistency, where one user's query sees new data while another's doesn't. And the small file problem. Oh boy. As data grows, just listing all the files can take forever. It's a total maintenance nightmare. All right, so how on earth does Delta Lake fix all of these headaches? Well, the core idea is actually brilliantly simple. It all comes down to one thing, the transaction log. So what is this thing? Think of it like a journal or a ledger that records every single change, every transaction that ever happens to your table. And the cool part? It's not some separate, complex database. It's just a set of files living right there in your object storage, right alongside your Parquet data. This log becomes the single source of truth, and it's what brings those glorious ACID transactions into the wild world of data lakes. And here's what it actually looks like in your storage bucket. You've got your data files, your partitions, all this stuff we're used to. But now you have this magic little folder, _delta log. Inside, you'll see these JSON files, numbered in order, 0, 1, 2, and so on. Each one represents a single atomic commit to the table. That, right there, is the beating heart of Delta Lake. So how does this prevent corruption? Well, when you write to a Delta table, it's like trying to be the first person to add the next page to a shared notebook. First, you check the latest version of the table. Then, you write out your new data files. Finally, and this is the key, you try to atomically add your new JSON file to the log. If you succeed, your change is official. If another process beats you to it, no big deal, you just retry. This ensures every write is an all-or-nothing operation.
Now, because we have this perfect ordered history of every single change stored in that log, it unlocks something amazing. I'm talking about Delta Lake's first real superpower, time travel.
I mean, seriously, think about this. A late-night deployment introduces a bug, and your most important table is now full of garbage data. Total nightmare, right? Or a data scientist asks, hey, can I get the exact data we had back in March for that model I trained? Yeah, good luck with that in a normal data lake. With Delta Lake, these aren't disasters anymore. They're basically a non-issue. And here's the best part. You get this for free. It's automatic. You don't have to turn it on or configure anything. Every single time you write, merge, update, or delete, you're creating a new version of the table, and the old one is kept safe and sound. You might think this sounds complicated to use, but it's not. It is dead simple. Look at this SQL. You just add timestamp as of or version as of to your select statement. That's it. You can literally ask your data, hey, what did you look like last Tuesday at 9 a.m. and get an instant accurate answer. It's incredible. Okay, so our data is reliable, it's safe. That's huge. But what's the point if our queries are slow as molasses? Well, that brings us to Delta Lake's second superpower, supercharging performance. Let's talk about the dreaded small file problem. We've all been there. Your streaming job writes data every minute, and before you know it, you have thousands of tiny files. Trying to query that is a nightmare for the engine. It spends more time opening files than reading data. Just look at this chart. A query goes from over 16 seconds down to under 5. The only change? Compacting all those tiny files into bigger ones. A massive win. So Delta gives you a couple of cool tools to fight this. Think of it as proactive versus reactive. Optimized right is proactive. It's smart enough to combine data as it's being written to create nice, big files from the get-go. Then there's auto compaction. That's reactive. It's like a little Roomba for your data lake, running in the background, finding messy partitions, and cleaning them up for you. But compaction is just table stakes. If you want blazing fast queries, you need to know about Z-ordering. The best analogy is a library. You could sort books by author or by genre. Z-ordering is like a mind-bending technique that sorts them by both at the same time, physically grouping related information together. It creates this powerful data locality across multiple columns. And the payoff is huge. Look at this. With a normal sort, maybe your query can skip 25% of the files. But when you Z-order across a few of your most common filter columns, you can suddenly skip over half the data. Your query engine doesn't even have to look at it. Less data read means way, way faster queries. Simple as that. All right, enough theory. Let's walk through a real-life scenario, a classic data engineering fire drill, and see how Delta Lake helps us put out the fire. Okay, picture it. Monday morning, you get a panicked message. The CEO's favorite dashboard is totally broken. Your first step isn't to panic. It's to investigate. You run one simple command, describe history. And boom. Instantly, you get this beautiful audit log of everything that's happened to the table. You see every operation, who ran it, and when. As you scroll, you spot it. An unexpected update from last night. That's our smoking gun. So what's next? We use our superpower, we time travel back to the scene of the crime, we run a quick select on the version right before that suspicious update, compare the data, and confirm, yep, that's what broke everything. And now for the magic fix. You don't write a complex rollback script, you just run one command, restore table. In seconds, the entire table is reverted back to its correct state. Problem solved, crisis averted, you're the hero. But a great engineer doesn't just fix problems, they improve the system. As a final step, you run optimize with a Z-order on the columns the dashboard filters on. Now, not only is the data correct, but it's also going to be faster than ever. Now, Delta Leak sounds pretty magical, and it is, but it's not a silver bullet. Like any powerful tool, you've got to know how to use it right. So let's talk about the fine print. First, there's no free lunch. Things like optimized writes add a little overhead to your write jobs, but you pay that small price for much faster reads. Next, and this is a big one, please do not over-partition. If you partition on a column with millions of unique values, like a user ID, you'll create millions of folders and destroy performance. Stick to columns with lower cardinality, like date or country. And finally, make it a routine. Schedule optimize and vacuum jobs to keep your tables healthy and your storage bill down. So there you have it. We've gone from the chaos of a data swamp to the order of a reliable, high-performance lakehouse. You get ACID transactions, the power to rewind time, and tools to supercharge performance, all in your existing cloud storage. So the real question to leave you with is this. Thinking about your own pipelines and your own data headaches, how could these capabilities change the game for you?